Just a kind of disclaimer at the start about this. This is really, going to be quite a basic overview of how we ended up having to use a scripting language in the Irish Film Institute. So just in case anyone thinks this is going to be about like image recognition or machine learning or anything like that, it's not going to be that deep or anything. So if anyone wants to leave now, this would probably be a good moment. I think they probably just scheduled us at the end because it is going to be quite light. But it might just give you an insight into our world and how someone like myself, who is not a qualified programmer whatsoever, I kind of just learned this on the job over the last 4 years or so. It'll be discussing, I guess, the problems that we had regarding the preservation of our digital objects within the Irish Film Institute, how we ended up finding that Python actually had a lot of the answers for these issues, and some of the outcomes, some of the things that worked really well, and then a long list of all my mistakes and regrets and everything I did wrong over the last 4 years. So just a quick word about the IFI for people who aren't. Like I specifically work in the Irish Film Archive. If anyone was ever out in the smoking area at the back, and there's a big glass building, we actually have vaults there for tens of thousands of cans of film, and I think over 10,000 videotapes at this stage. We also have a facility in, as of about a year ago, in UI Maynooth. But increasingly over the years, we've had to take in a lot of born digital cinema and broadcast donations and deposits. These are things that never originated in an analog format. Some of them actually weren't even files. We'll say a Digibeta videotape is purely digital, but you can't actually extract the files from it in the same way that you can somewhat extract the data from something like a DV tape. So our funding is 25% of it comes from the Arts Council. We get some more from our overarching agreements with the Irish Film Board, which has actually now been renamed to Screen Ireland, the Broadcasting Authority of Ireland, and then some extra services where we, if a film gets funded by the Arts Council, or any a TV show gets money from the Broadcasting Authority of Ireland, it comes into us. It's not quite legal deposit, because there is no legal deposit for moving image in this country. I think we're one of the few countries in the world that doesn't have legal deposit. But that's kind of roughly us. We have to generate a lot of our revenue from our cinemas, from our restaurant and bar and that kind of thing. And so, about me, I'm not a qualified programmer at all. I have a degree in philosophy and English literature. So largely, pretty much completely self-taught in this area. I started off working a lot with analog film and video. Worked a lot with 16mm and 35mm. Could be just cataloging or repairing, moving things through the assembly line to preservation storage and that kind of thing. Over the years, I've kind of focused quite a lot on the digital side of things. To be things like developing workflows for digitization and quality control, cataloging, different kinds of technical and administrative metadata and things like that. But also understanding file formats, and even sometimes, unfortunately, on a binary level, when things go really wrong, we have to take out the hex editors and stuff. And so I've been using Python for about 4 years or so, with pretty much just a little bit of bash before that, and maybe some basic programming that I would have used on a Commodore 64 many, many years ago. And so to give you a sense of some of the files that we might have in the archive, we're in one of the simplest things that we would have is you have a videotape, we digitize it, it produces one file. Some things might be a little bit awkward, some tapes might be broken up into multiple files, but in general that's not too bad. When we get into a bit further down, with modern digital cinema packages, any film that you would have seen in the cinema the last 10 or so years would more than likely have been on an ext2 drive, which would have conformed to the Digital Cinema Initiative standards. This is a folder structure that contains separate video MXF files, separate audio MXF files. A lot of times these will be split up into multiple reels. So you could have maybe 6 video files for pure image, 6 for audio. These are all fairly meaningless without the whole bunch of XML files. These are composition playlists, packing lists, asset maps. They contain checksums, structural metadata, and a whole bunch of different things that allow a projector to actually interpret these video files and play them back. Checksums are really, really important to archives, and one of the nice things about a lot of these formats here is that like they actually can get rejected by the projectors if the hash values don't match. And it also means that a filmmaker doesn't need to worry so much about the actual worrying about fixity and integrity and stuff like that. By making these packages, they actually come built in with checksums, which is kind of sweet. It gets a little bit more awkward then with the other two, like a film scan or a DCDM, digital cinema distribution master. The idea here is that this is like an uncompressed master that is then produces something like this, which is maybe a little bit more palatable. Unfortunately, like every single frame here will get its own file. So a feature film might have between 120, 150,000 files. Last week or 2 weeks ago, I had we got an acquisition in for a film from quite a major Irish director. That was 6.5 terabytes for about 90 minutes. And keep in mind as well that we store 3 copies on LTO. So we've ramped up quite high there, and we would have to view it. In terms of like, just think about the bandwidth that's involved in a lot of these. You have to view it, create checksums, validate checksums. It has to be, if we're extracting metadata, that's mostly going to access the header, but there are certain things where it might go quite deep. So we kind of go through hardware quite a lot. I don't know, like, I think at a certain point, like someone said to me recently, like, how big was a particular digital cinema package? This was only a couple of days ago. And I said, like, oh, it's only about 250 gigs. And he was, oh yeah, like that's great. I think we've lost all perspective on size working here. Maybe 6.5 terabytes multiplied by 3 is insignificant. I don't know what the context is in this room. But this stuff can get a bit tricky. It's why we like to wrap things up, if possible, into like I love normalizing film scans into a single FFE1 in Matroska file. FFE1 being a video codec, Matroska being a container. They're both open formats. It's a lot easier even from just dealing with bandwidth and I/O and that kind of thing to deal with one, or maybe to split it up. And of course then you have the joy of separate WAV audio as well on top of this. Maybe you've got other subtitles as well, and maybe you might, in some cases, have some XML files with like millions of lines of structural metadata to boot. And then something similar with camera cards. A lot of modern camera cards, like that's probably not one of those, but like an XT-Cam or a P2 or something. Most times, like filmmakers don't need to worry about this, but from our perspective, we have a similar issue here that we have here, which is every time someone presses record, creates a folder, has a video file with about 5 XML files. A lot of times there might be formatted to FAT32, so when it hits like whatever 3.7 gigs or something, it spawns up a new video file. Some of these cameras might have 2 or 3 card slots, so it starts spanning over. By just looking at it, you might not be able to tell that like those 12 files are actually all continuous, unless you start looking at the XML files inside of it. So in terms of like the work that we have to do, it really isn't just a storage issue. We have to, like one of the definitions from the Digital Preservation Coalition is digital preservation refers to the series of managed activities necessary to ensure continued access to digital materials for as long as necessary. Storage is just one aspect of it. Storage might, apart from the cost and the annoyances and stuff, is probably one of the easiest things. I know this is I'm not going to go through all these, but like these are some of the things that pretty much every archive library would have to deal with in the digital realm. And a huge amount of these can be done via Python or any scripting language, pretty much. One of them here, describe the works. That usually involves humans sitting in front of the work and describing where is this, is that De Valera, whatever. Eventually, we'll probably get to the point where we can generate models that'll automate some of this stuff. But for now, like we try to automate as much as possible to free up time for staff to actually do the monotonous tasks. We're a very, very small team. There's maybe 70 people overall in the IFI, but that's including like all the staff in the office and marketing and the education department, the bar and all that. In terms of like constant staff in the digital team, there's really just about 4 of us. And you end up doing lots and lots of jobs. Like coding is only like a small part of what I do. I have to actually do a lot of like admin and spreadsheet work and monitoring hardware and devising workflows and all sorts of things. In a lot of like higher funded institutions, you would probably have people doing all of these different things separately, but we have to like triple and quadruple job. In terms of like the drivers towards why we would have wanted to use some sort of a scripting language, it was largely, it's all kind of standards based. There are certain standards for digital preservation, maybe for preservation in general, that kind of guided us towards automation in Python. One of them here is OAIS, the Open Archival Information System. Was created by NASA, I think in maybe the early 90s, late 80s, early 90s. The idea here, this is kind of quite a chunky read, but it's pretty much every single archive that works with digital objects will have, that at least know what it is, and there'll be different levels of compliance with it. The idea being that you're not just storing objects, there might be, you have to think about who are you preserving these things for, who are you making them accessible to, what extra contextual metadata is needed to make this understandable. And perhaps you don't just need to be preserving the objects, perhaps you need to preserve an old operating system, or at least say that this might only work on an old version of, I don't know, what are some of the old word processing tools? Like, was it WordPerfect, there you go. These things, the converters don't work terribly well, and so you're finding out that emulation, like the first time I ever used a checksum was verifying like ROMs from SNES and NES and Commodore 64 rips and stuff like that. This stuff is becoming really, really relevant now. You hear like, I guess emulation as a service and all this kind of thing. So yeah, like OAIS, like it gives you a framework on how to package up these objects, what kind of contextual information is needed. It doesn't get 100% into the real world, I find. It's much more conceptual, where something like PREMIS, which is Library of Congress was heavily involved in this, the preservation metadata implementation strategies. It kind of gives a more concrete framework on how to, I guess, do digital preservation. It kind of focuses on things like objects, it can be serialized in XML, but like they say, look, you can use text log files or spreadsheets or whatever, just use the correct terminology and stuff like that. What are the objects that you're actually preserving? What agents are involved? These would be the hardware, software, people, organizations that do certain things. And then what are those things? The events. And it gives you a nice vocabulary of all the things that you should be doing and how to document them. So it's not just that you're doing a bunch of stuff, it's how do you actually document it. So you got to do loads of things and then document them. And scripting languages are really, really useful for that. So in like 2014 or so, I'm kind of like, things have changed quite a bit now, but a lot of digital repository tools, they were much more suited for images and documents. Like an institutional repository, like in a university, would be really set up for displaying a PDF of a thesis or something, or an image. You can zoom in on the image. An example of like, you know, if you had a preservation master or something like that video, you're getting into minimum, you know, a DV might be 12 gigs an hour. Even with lossless compression, you're looking at 40, 50 gigs an hour. So it doesn't work so well. You know, maybe you could put in an MP4 little low-res access copy, but then, and that's really good for access, but it doesn't really help with your preservation work. So we had like this monolithic tool. It was really more for an actual production house, like, you know, you're making a television program or a film, or you're like, I think the Discovery Channel might have actually used a similar system. It worked very well with single files. It didn't work with those complex objects that I was talking about. And even if you were to zip them up into a single file, like it didn't work with those either. Even if it did, it would just tell you this is a zip file. It's not going to help with your actual preservation work, where you might need to monitor the obsolescence of a file format. You might need to, I don't know, dig a little bit deeper into the header to realize, my God, we made a mistake in some way with this digitization in some way or something. And there was like a huge dependency on the vendor. We would ask them to support a more preservation-friendly format, and they would generally just say, no, there's no use case. You know, I guess Discovery Channel doesn't want this, so we don't care. And so I really like this think you can only access this now on the Wayback Machine, which is kind of relevant. But anyway, GIST Digital Media had this like guideline on file formats. And one of the things I really liked here, I think I put this up in every single slide that our presentation that I do. It was about how open technologies are less vulnerable to technical obsolescence. Maybe people here probably have a very different view of this, but I'd imagine it's roughly true. Support for a proprietary format can disappear along with the single company who developed it, but this is not so for an open technology. Again, it's very broad. I'm sure there's horror stories either way, but proprietary file formats can safely be used for delivery, but should never be used for long-term preservation where open alternatives exist. So we became quite interested in this FFV1 codec. It starts for FFmpeg Video Codec 1. I think some trolls at the VLC conference about 2 years ago came up with FFV2, but it was just, I think they were just messing around. So we've not gotten past FFV1 yet. Yeah, we asked the vendor, would you ever have interest in supporting it? And they just told us absolutely not. We realized that they had a little command line extender within their, I don't know, the back end of their GUI that you would set everything up. But like, it just still wasn't really suitable for what we needed to do. So I stumbled on the work of Dave Rice from the City University of New York, CUNY TV. I think they work in the Empire State Building as far as I know. He wrote this amazing article for the EASA journal called Reconsidering the Checksum for Audiovisual Preservation. So I think a lot of times when we think of hashes, maybe if anyone here deals with hashes and checksums, it might be more for security reasons or signing, that kind of stuff. In the archive world, it's really more for it's an easy way to check if a file is still intact, if it passes a fixity check. Are all the bits still intact? And we might think of it for like a whole file. This doesn't scale terribly well to video, which could be, one video could easily, it could be 2 terabytes. Some archives, we could have, like their entire collections mightn't even reach 2 terabytes, and that's just one object for us. So this was a much more granular way of thinking about integrity, where using FFmpeg, it would give you a hash value for every frame of your video, even if it's a single file. The reason this is significant is when you're thinking about file format normalization. You have an uncompressed video file, it's really, really big. We want to losslessly compress it down and make it smaller, but also something like FFV1 has like preservation-friendly features. It actually has checksum values for every frame built into the actual file. It actually breaks each frame up into slices. Each slice has its own checksum. It's really gorgeous because, each slice also has error correction. So it'll try and fool you into, like you'll look at it and you'll be like, it looks okay because it's duplicating the previous slice. But then there's tools that you can use and you can decode it and it'll say at 632 seconds in this slice, in this quadrant, there's an issue. It's super, super granular. But what it does is, going back to PREMIS and OAIS about the verification of your processes. Like, let's say a major filmmaker wants to give us their whole collection, and we're saying, okay, well, we'll keep your originals, but we also want to transform them into a more preservation-friendly file. I know if I was that filmmaker, I would get very nervous, and I would say, like, how do I know that you're going to do the right job or do the right thing? And the great thing about a workflow like this is that, like, we can generate logs, we can come up with proof to say, no, like the integrity has been maintained. We've transformed this, but it produces the same red, green, blue values. Like every single pixel that is displayed should display the same. And so what it does, it takes your uncompressed video file, makes a gigantic text file with hash values for, and these can be SHA-512, MD5, whatever you want. And then it does the same for your transcoded file. You diff them, you get a success or a fail. And that's how I kind of ended up stumbling into this whole thing. I wanted to do this. I asked Dave Rice on Twitter. He was really excited, I think, that somebody even read the article and wanted to reach out to him. And so this conversation quickly went to private messages where he was telling me, like he was saying just diff it, and I didn't even know what a diff was. This is how bad I was, I guess. And then he pointed me in the direction of his bash scripts. These are all available on GitHub. There were a couple of, like, there were a few things I didn't quite work for us. They didn't have to deal with some of the more complex objects that we had to deal with, like the digital cinema packages, the film scans. They were a broadcast house, so it was a lot of video files and stuff like that. I think originally I noticed that there was this line in here where it would just like delete the original video file if it passed the lossless transcode, and this freaked me out. So eventually I was at like doing reception cover one day, and I was able to read the code enough to realize, oh yeah, rm sounds like remove. But anyway, like it's just that was like I needed to, couldn't just start adopting this stuff without knowing more about it. So I kind of started writing my own bash scripts, and that was really nice. But eventually moved on to Python. Part of it was, like I was always like really insecure about this stuff as well. Like my, someone I went to college back here, Michael Deneen, would tell me every now and then that like you should just try out Python. And I really thought it was too stupid to figure it all out, or it wasn't for me, I didn't go to college or whatever. But I guess Python is actually for everyone if you just take the time to fail a lot and you have some idea of success. What does success look like? Like for us, I guess, you know, a good script, a good workflow, it was to adhere to preservation standards. Are we making archivists, and like, would the Library of Congress approve of our work or that kind of thing, or would Dave Rice approve of it? The secondary goal was kind of to be more Pythonic and write good code and documentation. I'm trying to get a lot better with that stuff now and writing doc strings and like getting I think I've got like, my read the docs PDF ends up being about 50 pages now, I think. There's probably too much documentation, if anything. But yeah, like the main driver was like, it was cross-platform. Back in like 2014, 2015, I didn't want to be messing around with, I don't know, like MinGW or Sigwin. I don't even know how to pronounce those things. But like, and I guess the Windows subsystem on Linux, whatever it is, that wasn't really around yet. So it's like, look, I'll just go with Python. I need to install this on Linux, we use Ubuntu, Windows and OS X. I want to have the same code and everything. So we actually have to use all of those operating systems for a variety of reasons. Yeah, so it just seems super easy to learn in the grand scheme of things. And what was nice was like, initially it was all just a bunch of procedures, do a bunch of things. And then eventually, what I liked about it was I got a good sense of like using things like Pylint and different guides to being a better programmer and being cleaner. I'll come to all my mistakes and regrets afterwards. Automation was a big one though. When you got such a small staff, this really helps. How am I doing for time? Jesus. Grand. Okay, so it's all available on GitHub. Like from the first commit, like there's such, in retrospect now, such naivety about it. I heard a talk earlier on downstairs, and it seemed like people publishing their code early was like, I don't know, maybe people are embarrassed or something. Like I was like shameless and I didn't care. So it's all there. We've got about like 1,443 commits right now from 10 contributors. I'm really proud that some of them are non-IFI staff. We've people from the States and Europe chiming in. And they're all just command line tools. Yeah, and like everyone gets training in the IFI. Like anyone who works with digital collections uses the command line every single day, whether it's on Windows, Linux, or OS X. And everyone has got a GitHub account. They're reporting bugs. Got like hundreds of issues that have been closed and about 83 open issues, sorry. There are some of the read the docs documentation. Not everything is there. I just tell people to like script name -h, and that's probably like way better. This is probably completely useless, but some of the libraries we use, because I find it interesting that some folks might actually never use subprocess that much, or hashlib, or because that's not how your work goes. But everything we do is pretty much command line based. And in the last couple of years, this is from an EMEA open source, the Association of Moving Image Archivists. We have an open source group where we help each other out a lot. We share. Anyone who's in this particular strand of digital preservation are really, really into sharing everything, sharing our knowledge. We try not to be gatekeepers in any way and try to encourage other people to pick this stuff up. There's like some really like good names doing similar work. I guess it's like moving away from the monoliths, writing your own scripts. You know, National Library of New Zealand, Carnegie Hall have really good ones. New York Public Library have got really, really nice Python work as well. Yale, American Archive of Public Broadcasting. And in terms of, yeah, okay, mistakes and regrets. I'm probably it's gonna sound super negative now because I won't have enough time to talk about everything that went well. Yeah, so it was really about fulfilling digital preservation standards. That's the primary goal. And so I created a huge amount of technical debt then as a result, because things were working actually super well, and then it became hard to refactor later on. Not creating unit tests hurt me so much, hurts me to this day. It takes, like, we don't have a lot of bureaucracy where we're at, so we can just push changes really easily. But it's just becoming more and more difficult now because I have to do a lot of manual testing when we want to do a new workflow. So with the move to Python 3, oh, that's another one. Listening to Zed Shaw and choosing Python 2 over Python 3, that hurt quite a lot. But the move to Python 3 was actually kind of fine. I use print a lot. I should use logging. I think that's probably really bad. I used to just like read Stack Overflow and different blogs quite a lot, not reading the actual Python documentation, which is incredibly user-friendly and helpful. Not using a lot of classes and object-oriented programming. That actually would have made our life so much easier. Some of our functions like just return a million different things, and they're really awful. But I'm getting better with all that stuff. And also, generally like a poor package structure, you can install it with pip install IFI scripts, but it's quite old. We're taking the FFmpeg model where like git master is the live version. FFmpeg have versions, but they're like, we only support git master. So it's the same with this. Our scripts generally, like you're running it directly from master. That's probably terrible too, but it works okay for us. And the things that went well, it inspired actually loads of other different projects. UC Berkeley, the BAM, the Pacific Film Archive, they would cite us as the inspiration for their work, or some of their work. They other people as well. Moving Image Archive of Central England, Joanna White in particular, would cite the IFI's approach to it as inspiring their work. Just like last night, somebody from the San Francisco Symphony got in touch saying, we want to use some of these scripts to migrate files to LTO. And it's like, that's really nice. Like you hear random film festivals and archives who actually start using these things and hack them and do whatever. It's kind of weird. And generally there's like just a love of Python now. Yeah, we won some awards too. Again, like this was nice because with the goal being making our fellow preservationists happy, like beating the White House archives and the UK Parliament archives. That was pretty sweet. And then recently we got an award from the Joint Technical Symposium. This is like an overarching group of all the major moving image archives in the world. And they acknowledge that we're doing maybe good work and stuff. And it raised the profile of the Irish Film Institute as well, more from the archive, that we're kind of, quite open and sharing and doing work that's maybe, I don't know, somewhat innovative, I don't know. There are some links to things. But that's it. It's just like, I feel like such an imposter standing up here because I'm literally the worst programmer in the building, I would imagine. But I think there's probably still a place for me here as well. And it's nice to be able to talk about this work and to let ye into our world a little bit. And it's just so great that Python is so easy. There's so many great resources and so many great users of Python. It's like, if it wasn't for people like Michael and Zach Kelling in the States who just told me a couple of times to just bear with it and stuff like that. Keep trying and keep failing and fail better and all that kind of stuff. Yeah, so look, that's pretty much it. You can check out the code and cringe. But actually, you know what? Some of it's actually, I'm very negative about the whole thing because I'm really self-conscious. But like, I reckon the code's pretty good overall. Like, cheers.